So in our previous C++ course, we spent a lot of time actually building our own collection classes in C++. So essentially what we're going to do is we're going to replicate that a little bit in C Sharp. We're going to find it's maybe a little bit easier because there is some shortcuts to doing so. So we're going to start off by creating a collection class, a collection of Cartesian points. The class is going to be called PointList. So we'll start off by, again, opening up the pointslist.cs file. While you're here, you might as well replace the second author where it says your name with your actual name, and you can update the sin state as well. So the idea behind points list is that it's going to be a vector-like or an array-like class, collection class, and what it actually collects or stores is a list of Cartesian points. Okay. Now, one way of doing this is to implement all the required methods manually, much the same way that we did it in C++. But this is going to be a time-consuming and a complex process. So another way we can do it is actually derive a new class from one of the existing base collection classes. So there's a systems.collections namespace, and one of the classes that we can inherit from is an abstract class called, again, collection base. So we can inherit from this base class and just add the functionality that we want or override the functionality that's built in as we see fit. So to start off with, let's add a few basic methods, starting with the, no pun intended, the add method. So this method will be public, doesn't return anything. It's called add, and what is it that we want to add to a points list? Well, we want to be able to add a Cartesian point. So Cartesian point, and I'm going to call it new point. That'll be the name of the parameter. All right. So in terms of what we do inside the method, we can use the word list, which is actually going to give us access to the array list that actually stores the items. So for example, it would be list, okay, which you can see there, it pops up, dot, and then the actual array list has an add as well. And normally that add just takes a generic object. We're actually going to be supplying it a Cartesian point, so it's the new point parameter that we just defined. Okay, so that's really all there is to that. And of course, we could add some added functionality if we want to. An alternative way of going through and doing that is instead of using list, you can actually use the name of the object itself, which is the array list that stores it. So we can say it's inner list is what it's called. So inner list dot, and then the rest of it is pretty much the same. So add new point. Oops. Semicolon. So these two things essentially do both do functionally the same thing. So I don't need to do both. So I'll comment one out. All right. So that's the add method. Now there's a few other methods that come with array lists that will probably be handy for us to use. So I'm just going to show you a couple of them. It's not a comprehensive list, and you can check out the documentation that I've put in the solution, but I'll just add the three of them here. They're little short ones. I've elected to put them in this style, just one line each, but more properly I would have separate summary tags, etc. for all of them. But at any rate, insert. Basically I send it an index, an integer index, a Cartesian point, and I use list.insert, and I pass through those to actually do the functionality. Here's another one. Remove. So I'm removing a point. Okay, so a Cartesian point is what the parameter is, and I'm using list.remove. It normally takes an object. I'm sending the Cartesian point to it to remove a Cartesian point from the list. And here's another one. It's actually a bool function, returns true or false. It's called contains. It's basically looking to see if a Cartesian point, this particular object, it's a Cartesian point in our case, is actually in the list. So I'm returning list.contains and just passing through the point. So you get the sort of the pattern here of how to do this kind of thing. and you do this for as many methods as you really want to. Here I can really very quickly show you some of the methods. I'll do it here just by using IntelliSense. So list dot, and there through IntelliSense you can see there's a number of other methods that you might be interested in implementing. So I'll delete that. Don't need it. So in addition to implementing these various different methods, one of the things that we'll probably want to do in almost every case is give our class the ability to access the list through a subscript. Okay, so to do that in C#, to do that in C++, we overload the subscript operator, but in C#, what we do is we actually create a special kind of property known as an indexer. So the basic syntax is we're going to make this a public property. The property is a Cartesian point. Okay. The name of this property is this. Okay. We've seen this keyword before. And then in square brackets, okay, this is where you name whatever you want to call your index. I'm going to call it int point index. Okay. So again, it's a property, so I don't put a semicolon here. I open up a brace instead, and I'll use my get block. So what do I want to do when I'm trying to get so I want to return the Cartesian point. Oop, that doesn't say return. Okay, so I want to return the Cartesian point, so I'm going to be doing some typecasting there. Okay. Okay, the list at position point index. Okay, so that's pretty straightforward. Now I need this explicit casting because I need to be returning a Cartesian point, and what the indexer for list normally does is returns an object. So this typecasting bit, it actually is important. So I'll add a bit of a comment here to remind myself of that later on. So next we'll code the set block. Okay, so it's simply set, and I want my list at position point index equal to the value that gets sent. And then of course I'll close off this property. And oh, it's gone and fixed my comment indents for me. I don't like it that way, so I'll fix that again. All right. So I'll save this, and I'm going to go back into main, so program, and let's try some of this stuff out. So underneath part 1, the basic PointList class, and we'll fill some of this stuff out so we can actually see that it works. Okay, so let's create a new empty point list. So we use obviously the name of it, PointList. I'm going to call it my list, and I want to make it equal to a new point list. Okay. So that's pretty straightforward. It says add 2 new points here. I don't like that. I'm going to add 3 new points. All right. So how do we actually add points to the point list? Well, it'll be my list dot add, and then it takes a Cartesian point. Now, I don't have any Cartesian points declared, but I can say a new Cartesian point. Okay, and I will arbitrarily pick 3, 4 for my coordinates. And that should do the trick. Okay, so that's adding 1 of them. And I'm just going to do a little copy and paste here. And I'm going to add, again, 2 more. So, and we'll change the coordinates. So for the second one, instead of 3, 4, let's make it 88, 99. And for the third one, I'm going to make it 5, 5. Okay, just to be different. Next, we want to show the points. So I'll do a little console.writeLine. Here are the points stored in my list. And I'm going to do a for each loop. So how am I able to do a for each loop with this particular class? So because my class, my points list class inherits from collections base, it actually supports an interface called IEnumerable. And IEnumerable is what allows us, it includes various different things that allows for each loops to work. So without doing anything or coding anything in terms of enumerators and iterators and that sort of stuff, I do have the ability to use my objects of my class with a for each loop, which is kind of cool. Okay, so I'll have a little for each loop here, and I'm just going to do a console.writeLine probably here. There we go. So I'll output a tab. I'll do concatenation just to be different. The point that I'm getting from my for each loop to string. All right, I'm just going to scroll down a little bit in the sample code that I made. I'm going to uncomment. You'll notice that it says pause the program, right line, press any key to continue, and then console.readLine. I'm just going to uncomment that console.read key. If I were to run this right now, if I didn't uncomment that, I wouldn't actually see this output because the next thing it does is clears the screen. So let's just run it at this point. Okay, so I'll say start. And here is our output. So after adding, here are the points stored in my list. And there's my 3 points. I have a 3, 4, 88, 99, and 5:5. Press any key to continue. And that's basically the end of the program right there. Next thing that we'll do is we will add a new point at the very beginning of the list. Okay, so that should be pretty straightforward. It's my list, right, dot, and then I have an insert. Okay, I want to insert at the beginning of the list, so I want it to be at position 0. And then what point do I want to add? So I'm going to add in a new Cartesian point, and I'll make it, oops, 0, 0. Okay. So now I want to do basically the same thing, show the various different points, but this time I'm going to be using a for loop instead. Okay. All right. So I just have a little console.writeLine here saying, you know, I've inserted a particular point, and here are the points in my list. So I'm using, again, the subscript operator to get to a particular point in my container, my collection, I should say. For loop, you know, I have an integer counter. I'm using the count property that I inherited from collection base. Each time I'm incrementing the index by 1, and you can see here I'm using in my actual loop not only the index, so I can actually see my list 0, my list 1, my list 2, but also the actual Cartesian point stored at position index, and then converting it to a string, which it probably would do if I left it off, but I throw it in there just to be explicit. Okay, so we can try that out. Okay, so we have our original 3 points, and then after inserting 0, 0, here are the points, and you can see I have a little bit more control with a for loop, right? I'm able to output more information. Okay, so we can see it more explicitly there. All right, next thing we're going to do is we're going to remove a point. So on the line where the comment says create a reference to the point we want to remove, what we're going to do is we're going to create a new Cartesian point, or rather we're going to create a Cartesian point object. Let me get caught up here. So a Cartesian point object, we'll call it a point. I'm not feeling very creative right now. And I want to make it equal to, I'm not making a new point here, but I'm making it equal to an existing point. Let's say my list at position 2. So this is a reference to an existing point. Okay, just another name for it. And now I'm going to actually remove that point. So it'll be my list. Okay, dot remove. And what point do I want to remove? I could say my list at position 2. There's also a remove at method if I just wanted to say position 2. But I'm going to say a point. Okay, so that will actually remove my list at position 2. So let's actually go ahead and show that as well. What you may want to do here is just copy the loop from above, and we'll make some slight modifications to the output here. So after removing, okay, and it's not my list 0, we'll say a point. So after removing a point, here are the points stored in my list, and then we'll see them after we've done that removal. So let's go ahead and run that. Okay, so after adding, there's the original 3. After inserting 0, 0 up at the top, everything moved down by 1. After removing 88, 99, you can see the 5, 5 moved up 1. Okay, so basically things are working well with our basic class. Okay, so this has been a long video. In our next video, what we're going to do is we're going to look at iterators in more detail. Thank you very much.